then I'll only talk about it for about 4 minutes. The switch statement will look very familiar if you've taken Java. It will look unfamiliar if your exposure is via Python. So what you use it for is to replace a series of ifs. If you have a whole bunch of ifs based on the same control variable with discrete values, so if you have a whole bunch of if-else ifs all based on the same control variable, and the control variable is an int type, so it can be an integer, it could be a character, it could be a byte. You know, there's all sorts of different ints in this language. Then you can use a switch. So like this, x is equal to 3. You could write if x is equal to 1, you know, see out something. Else if x is equal to 2, see out something else. Else if x is equal to 3. Oh, I made a serious mistake up there. Anybody spot it? See out 3. You see that line right there? It wouldn't even compile at this point because of that. That line would compile, but then it would hit this else and not compile. Just never put a semicolon after an if or a for. Alrighty. You're right, you're right. And then see out, I don't know. Okay, so if I want this to be correct code, I would come up here and define this as an if. That's our demonstration code, and I'm going to rewrite that as a switch. So switch on x, case 1, see out 1, and then break. Do you need to put that all on one line? No, probably not. This is more standard styling. If you feel like it, you can put braces around it, you know, like that. Don't have to. Case 2 colon, see out, you know, 2. You see where this is going. You see how this is almost exactly the same in its own way as the other one. Case 3, see out 3. Don't know when I started adding spaces before. And then default. See out, I don't know. You don't have to have a break on the default because it's the last thing. Wouldn't hurt it. Okay, so hopefully you see how similar these are. Right? If x is equal to 1, come on, Mr. Mousy. Print. Yeah. If x is equal to 1, print 1. If x is equal to 2, print 2. If x is equal to 3, print 3. The only thing that this thing does differently than those other if statements is if you start leaving out break statements. Then you have fall through. If it was case is equal to 1, it would print 1, but then it would also print 2. And it would keep falling through until it finally hit a break. So at this point, if we passed in a 1, it's going to print a 1, a 2, and a 3, and then it finally hits a break, and so it stops. If we passed in a 2, it would skip that one. It would leap right here. It would print out 2. It didn't find a break, so it fell through, and it printed 3. It did hit a break, and so it stopped. If we passed in a 3, it would bypass everything else. It would print that out. Then it would hit the break and bail. And if it wasn't equal to any of those values, then it would print I don't know, just like our final else there. I suppose that if you left that final one out, it would go straight into the default clause and go ahead and print that as well. Now normally you don't want fall through. The circumstances where you want fall through are very, very rare. So if you are going to exercise fall through, leave the word break in it and then explain why you're doing it, right? Give the next programmer who's coming along after you a little break. Let them know. Let them point out, because otherwise they're going to see the missing break and they're going to think that you're an idiot and they're going to go ahead and add the break. All right. So hopefully that's enough. I'm pretty sure that we did this already, as everybody has said, so I don't want to actually write another program. Do read about it in the book. Here they're not showing the breaks, which means that as soon as it jumped to 1, it would keep going and printing out statement 2 and statement in and going to the default. But in their example, they do it correctly. If you typed in A, it prints out you entered A. That's about as brilliant as my own example. Case B, print you entered B. Case C, print you entered C. Default, you did not do any one of these. So that density project that we did where we had the sphere and the density of gold and stuff like that, that easily could have been written with a big case statement if it was not to begin with. I don't recall. I think it was just a bunch of if statements. Which did we do?
Sphere, yeah.
That was if statements on the sphere? Yeah, okay, that's what I thought. It'd be real easy to rewrite it so that it use switches. So the switch statement requirements, the expression must be an integer or an expression that evaluates to an integer. And they must be constant integer expressions. That means that you can't say case y and have it compare. Well, is x equal to y? Then do that. These have to be unnamed constants or named constants. Just can't use variables in these cases. In other Java languages such as Java, you can switch based on other types. You can switch on strings as well as ints. Not this one.
You showed us that you can do switches on characters.
Yes, you can. You can switch on characters because ultimately a character is an int. It's just an 8-bit int, large enough to hold a value between 0 and 255. That's the end of that chapter, I believe. More about blocks and scope. The scope of the variable is a block in which it is defined. Usually you define your variables at the beginning of the function. You can define them right before you use them. So in this code right here, if I wanted to, I could do this. I don't know what I'm doing here, but you know, say I wanted to do set y equal to 7 if that was the case. Well, I could declare my variable right here if that's the only place that I'm going to use y. But if I want to share that 7 amongst other if statements, for some reason, I would have to define it above everything, like that. So if I didn't do that, since this is defined within that pair of braces, it is within scope within those pair of braces, and it's not available anywhere else. Now you can do, in many languages, and I believe this is one of them, something called data hiding. If I did this, int y is equal to 20, 10, whatever. When it got down here, it would create another variable called y, which for the duration of this scope would equal 7. But then when we fell out of that block of code, then we still have this one, and nothing ever changed its value. Now that's weird, but I believe that to be true of C++. It's not true of some other languages such as Java. I'm going to take those examples out. I think we already have the idea of scope. Scope is just a lifespan of it. The variable is available between where it is defined and then the closing brace of the block of code. If you want a variable to be available anywhere throughout that file, you define it as a global variable, meaning you define it above main. And global variables are frowned upon, so find other ways of doing it. If you're going to use global variables, put them in a namespace. A namespace, whatever you wanted to call this, you know, my code. Would you have to put it in caps? No, that looks pretty stupid. And, you know, then you could define your global variable, whatever G was supposed to be. And then later on in your code, when you were ready to use that G, you would just do my code : G is equal to 10, like that. You could even call it namespace globals if you wanted to. Now for this example to be proper, I should go ahead and, you know, have everything right like that. I think I will not spend the time doing that right now. Return 0. All right, like that. All right, so in order to use this, since it was defined in a namespace, we had to prefix it with the name of the namespace. If we didn't want to do that, we could use a using statement. Using, and what would I put here? Just like we do using std,
Using my code.
we would do using my code, and then we could get away with using the stuff that was defined within namespace without prefixing it. All right, onward and upward. Yeah, two variables with the same name. Here they have defined a variable called number, and then later on inside a new block of code they've redeclared it, but they haven't redeclared it. They've declared another variable named number. And if they reassign that one, it doesn't change that one. And that one disappears as soon as we hit the closing brace. Weird idea, but that's called data hiding, because we can no longer get to that variable in here because it's now using the one that's closest to it inside there. Now, if you tried to define two variables in the same scope with the same name, it'll give you an error. But it's not the same scope if it's got, if we're inside of, another pair of parentheses. Wow, sure to give us a lot of time on the cell phone program. Maybe I'm happy stopping there. Yeah, I had one about a switch statement, but I don't think that we need to redo that. Okay. Because if I think about it, I think our cell phone program used that anyways. Let's go look. Yeah, we did use the switch in a case. So we've already got that. I'm ready to hit chapter 5 now. Hopefully that's a raise. Nope, loops and files. All right, we're not going to talk a long time about whiles because you've already taken classes in which you've learned about whiles. We will talk about the syntax of the for loop. And then we hit our first reference to using files. So plus plus is the same thing as plus equals 1. And I know that I've talked about this one to death, so we're not going to spend any more time on it. VAL plus plus is the same thing as val equals val plus 1. You can use prefix or postfix. One thing to know is that this one is marginally faster to evaluate. It saves a couple of clock cycles for reasons I don't really know. But if you're writing code at the absolute maximal speed, then do plus plus val rather than val plus plus. Now I'm trained to do that because we've used so many languages, you know, where you did val plus equals 1 or val plus equals 10 or whatever. So I always just default to that. But if you were going for max performance, then you prefix it with a plus plus. And you can also use minus minus to decrement. If you need to add more than 1 to it, you wouldn't use that. You'd do val plus equals 2, right? Or whatever. Just the same syntax that we've learned in Python. I trust that y'all have learned that in Python. I haven't had many of y'all in Python. You know, val plus equals 10. Val times equals 30. Like that. Like that. You know, we've already had that stuff on an exam, so I'm real sure that we've done it. And we've talked about this. In prefix mode, the operator increments immediately. It's the very first thing done in the expression. In postfix mode, the value is returned, and then it's the last thing for it to happen to get incremented or decremented. So, introduction to loops, the while loop. We've been using this since day 1 or 2. While expression, do the statement. Expression has to be a Boolean expression, something that evaluates the true or false. Statement can be just 1 line of code, or if you want more than 1 line of code, you enclose it in braces, just like the if statement. You know, it's pretty much exactly like an if statement. If the expression is false, it will not execute that. If that expression is false, it's not going to execute that. If this is true, it's going to repeat that. If this is true, then whatever this is had better somehow change that expression, or there better be a break statement in it, or else it's going to be an infinite loop. Because if this expression never becomes false, then it'll never break out of the while statement. Their example, int, number is equal to 1. While the number is less than or equal to 5, print out hello and add 1 to number. This part is necessary, and when I'm demonstrating while loops, I always forget that part, and I wind up with an infinite loop. That's why I like for loops. You never forget the increment in a for loop. But anyways, it'd add 1 to it, then when it hits that, it would check again. This is what's known as a pre-test loop, meaning that the test happens before the body of the code. And in Python, that was the only kind of loop you had. So, x is equal to 3. While x is less than 10. Nope. You know, and then cout x endl and add 1 to x. So what is that going to print out? I'm going to lower this number. So x is 3. Is x less than or equal to 5? Let's pretend we're doing C rather than Python, so we have to do our parentheses there. Is x less than 5? Yeah, it is. So it's going to print out 3. Then it's going to add 1 to it. Then it's going to recheck the condition. Notice that the check happened before the body of the code. So after x plus plus, it was equal to 4. Is 4 less than 5? Yeah, it is. So it's going to print out a 4. And then it's going to increment x once more. X is equal to 5. It's going to run back up, evaluate the condition one more time. Is 5 less than 5? No, it is not. So it's going to stop there. What if we changed x to something that was not less than 5 to begin with? X is equal to 10. All right, is x less than 5? No, so it's not going to print anything. There's also something called a do loop, which you did not have in Python. It is a post test. So while loop is pre-test, meaning that the test occurs before the body of the loop is executed, performed. A do loop is post-test, meaning that the test is done after the body is performed. And in some cases, it seems to work exactly the same way. X is equal to 3. Do some code. Cout x followed by ENDL, and then add 1 to x. That's going to print the same thing. It's going to print 3 and 4. Or will it? Let's look. Maybe I am speaking with forked tongue. X is equal to 3. Do this stuff. Print out x, so it's going to print out a 3. Add 1 to x. And I forgot the rest of the loop. This would not have compiled. What's wrong? I don't have a condition here. While x is less than 5. That's what I needed. And here's the only time you put a semicolon after a logical construct, like an if or, or a while or for or anything like that. We just have to tell it what the end of the do structure is. Okay, so it's going to print 3. It's going to add 1 to x. It's going to hop back up. Well, before it hops back up, it checks it. So this changed it to 4. Is x less than 5? Yeah, it sure is. So then it's going to come back up here and print it out again. Then it's going to add 1 to it. X is now 5. Is x less than 5? Nope, it is not. So it is done at that point. And that's the same output we got from wording it like this. But if we set it to an invalid, well, no, I won't call it an invalid value. If I take the same block of code and I set x equals to 10, is it going to print anything? It sure will. Do this stuff. See out. X is less than it's going to print out x here. It prints out 10. It's going to add 1 to x. X is now 11. Is 11 less than 5? No, so it's done. But it did print out 10. Whereas when we set x equal to 10 here, it didn't print anything because this is pretest. It got tested before the body of the loop. This is post-test. It got tested after the body of the loop. There are general rules of thumb. And I shouldn't talk about the rules of thumb until we've talked about for loops, but you've already heard of for loops if you've taken a Python class. So for loops you use for a discrete range of values. For x equals 1 to 10, that kind of thing. Do loops are used when the body of the code must be performed at least one time. And in a while loop is when those other two cases don't apply. When for or do does not seem adequate to your purposes. But why don't we just put in other cases? Now honestly, there's absolutely nothing you can do with a for loop that you can't do with a while loop, and vice versa. It's just that a for loop is a better syntax. So that's your test expression, while number is less than or equal to 5, and then that's the body of the code that's subordinate to the expression. So it gets performed if the test expression is true. The while loop is a pretest loop, meaning that the test occurs before it enters the body of the code. Watch out for infinite loops. The loop must contain code to make expression become false, or there had better be a break statement. If either one of those things is not true, the loop will have no way of stopping. So if I wrote my loop like this, x is equal to 3, while x is less than 5, C out x followed by ENDL, it's just going to print 3 forever because nothing ever changes it. I keep mentioning the break statement. Break will force an exit from the loop. So if we had some kind of if statement in here, if whatever condition was true, then break, then it would leave that infinite loop, but that expression would have to be true. Now this example is not set up in a way that that would work, so I'm just going to delete that. Infinite loop, while int number is equal to 1. While that number is less than 5, go ahead and print hello. Nothing ever changes this, so this test expression never becomes false. Using while for input validation. Now this is actually some really good stuff. Input validation is a process of inspecting data that is given to the program as input and determining whether it is valid. I meant to bring in the code that would show you how to make your program accept, all of our programs have gone nuts if you typed in a letter rather than a number. And so I had the code ready to show y'all about how to fix that, and I didn't bring it in. So I'll try to remember to do it Thursday. But anyways, the while loop can be used to create input routines that reject invalid data. And we may as well go ahead and get this to work. And I bet we've done a little bit of this in the past, but we're going to go ahead and hammer it into our brains now. So I'm creating an empty project. I'm going to put my boilerplate in it. Include IO stream, include string, using namespace std, int main, system pause, return 0. All right. So what I want is I want to ask the user, say, to enter an even number greater than 0. And if I was doing this for my own purposes, I would probably make this a function. But let's tell them what we want. But let's make a loop variable that we set to true when we finally have valid data. So I'm going to define a variable called data. That's going to be our number, whatever data means. And then we're going to create a variable called valid. And we're going to initialize it to false because we don't have any valid data yet. That would be a little bit better. Notice that that worked. If we printed out valid, I wonder what... Okay, I have to find out. Probably going to print 0, but then when I change it to true, is it going to print a 1? Just want to make sure. Don't do this, guys. Change that to a bool right there. Should be bool valid is equal to false. Yeah, print it out as 0. If I change this to a true, is it going to print out 1? Just want to make sure that my understanding of the universe is correct. Yeah, okay. So anyways, change that back to false and make that a bool. Delete that. Okay. So we're going to do this. While there's always more than one way to write it. While not valid, or while valid equals false. I'm going to write it that way. While valid is equal to false, although a pro C programmer would think that you were being silly and that you should have just used while not valid. Let's ask them. Enter a positive even number, integer. Colon, space, end quote, semicolon. Now let's read that into data. Now we're going to check data. We're going to see if it's true. If it's good data, we're going to set valid equals to true. Otherwise, the loop's going to repeat. So if data is greater than 0 and data mod 2 is equal to 0, because that's how you check to see if something is even, then valid is equal to true. Now that code's going to force them to enter a positive integer. Now we probably ought to tell them what's wrong. We should say that wasn't an even number, or it wasn't greater than 0. It's not very friendly just to keep telling them enter a positive even int. So I probably should have broken this out into several if statements. Firstly, we make sure it's greater than 0. And then we make sure it's divisible by 2, and we print error messages upon each case. But I didn't do that, so I'm just going to put an else here. Else, cout, not valid, try again. And let's give that a shot. It says enter a positive int. Firstly, I'm going to make sure it works. I'm going to type in a positive int. Alrighty, what have I done wrong? Okay, if I type in invalid data, it does tell me, but it's not breaking out when I typed in good data. And do I see why? I'm setting valid equal to true there, so that should cause it to break out there. Honestly, guys, I'm a little bit stumped. I guess I'm going to wind up rewriting this if statement, breaking it into 2 cases. Okay, the first thing I'm going to do is I'm going to set valid. Don't type this because I'm still confused as to why it's an infinite loop.
Put valid equals true.
That would do it. That would do it. That would do it. What is wrong with this line of code right there? Yeah, when you do if statements, you need those, but when you do assignments, that should be a single equal.
True.
Yeah, all it was doing was comparing, and it wasn't even storing the result anywhere. So it was valid code, no pun intended, but it didn't work. All right, enter a positive int 12, pressing the key to continue. So that worked. I'm going to type in a negative value now. Negative 10, not valid, try again. Now see, it would make sense to tell them what was wrong with it, and I didn't.
Cout statement that says like good number or whatever when it does work.
Right, that would be better. I should add a statement down here at the bottom. And by the way, I'm going to delete some of my curly braces so I can get more code on the screen at the same time. Cout, good data. Like that. Enter positive int, 9, not valid, try again, 10, good data. If I was going to rewrite this to be a little bit more friendly, I think I would do it like this. I'm going to go ahead and delete that if data line and that valid equals true line. And I'm going to say if data is less than or equal to 0, that means it's negative. So cout I guess we haven't decided whether 0 is a positive int or not. Number cannot be 0 or less. Now, if it survives that test, else if data mod 2 is equal to 0, because that's how you check to see if it's an even number, then we have another error message we can print out. Cout. Oh, wait. Can't do that. It should be data %2 not equals to 0. So I need to fix that line. Else if data %2 not equal to 0, then we print number must be even. And we hope they know what that means. Finally, else, if those things aren't true, then we have good data. So valid is equal to true. And I'm going to clean up my curly braces again, just to make things pretty. And that would be a good place to actually print out our good data message. Okay, so that's our while loop that validates our data. And honestly, I would prefer to make that a function and put it above main, because that's a lot of code to do just every single time I want some good data. And I kind of feel like doing that. So what I'm gonna do, and then I'll do walkabout and make sure that we're all good. I don't want to confuse the issue too much, but I'm gonna take everything, just flat out everything, from int data all the way down to good data, right? All of that stuff. And I'm going to put that in its own function. So I'm going to steal all that stuff right there, and I'm going to cut it out. And I'm going to go up above main, and I'm going to define a Boolean function. No, it's got to return data, so it's got to be an int. Int get even number, or get even int. And I know I'm going to need to return the data that we finally got, so I'm going to add a return data at the bottom, but then I'm going to paste right there. It's just underlining because I haven't declared the data variable yet, but that's declared in the code that I'm about to paste. So, paste that stuff that I cut out of main, and now we have a function that we can call whenever we want our even number. Like, let's declare x. And x is equal to get even int, like that. And int y. Y is equal to get even int. This is the kind of code we would write if we were going to check to see if they entered something really bad, like a letter rather than a number, or they typed a floating point value rather than int. We would just modify this code to perform some more checks to make sure that it was not bad. All right, I made a lot of changes. I need to make sure that it works. Enter positive int 9. Number must be even. Enter positive int -2. Number cannot be 0 or less. Enter a positive even int 2. Good data. Now it's not telling me whether it wants x or y. So that's kind of a drawback there. We should put some additional information there. I'm going to delete this int y. Y is equal to get even int. But I am going to put a message above it that says, I need the value of x, please. Like that. Just to differentiate it between anything that we then ask for input below. All right, I'm going to scroll up so that we can see the beginning of this code. Wow, a bit long. I guess I will make the font one click smaller. All right, I do want to make sure that everybody's got this, so let's pause. So here's the general approach in pseudocode. Now this is a different method than what I just showed you. This is showing what's known as the priming read, where you read the data, then while the input is invalid, you display an error message and you read the data again. I don't like doing it that way because I don't like having the input done in two different places. I'm going to go back to my code and I'm going to show you what it would take to get that to work. But I don't really want you to make this change. I'm going to just copy that code, and like I said, don't make this change. I'm going to call it get even 2, int even 2. Here's what I would have to do. I would have to ask them to enter a positive even int. I would read that in. Then I would need a while statement that consisted of all of this if stuff. So while data is less than or equal to 0, and data %2 is not equal to 0, then tell them it had to be 0 or less, or to tell them that it's invalid data and must be even. And then ask them the same question again. All right, maybe that looks cleaner to you. I don't like it because we had to write our input and our output here, and then we had to repeat that right here. It bugs me to have the input and the output in more than one place. Also, it didn't let us generate, you know, the reason it looks so clean is it's not telling them what they did wrong. Here, we're telling them what they did wrong. Yeah, if we weren't telling them what they did wrong, you know, like we did originally, this code would look cleaner as well. So the book is going to show you the priming read. Priming mean, you know, like priming the pump. You have to, you know, get that to happen before you go into the while loop. That's what's known as the priming read. And then you check it, and as long as the data is invalid, you tell them so and you ask again. You feel like doing it that way? That's totally legit. That's how most textbooks show you how to do it. What's the advantage of doing it this way? In my mind, it's because we only ask the question, we output it in one place of the code. What's the price we have to pay? We have to declare another variable here. So, just depends on which way you like. Enter a number less than 10. They read it in. While the number is greater than or equal to 10, we yell at them, invalid entry. Enter a number less than 10, you silly fool. And then we let them type it in again. And you can see what I mean. This stuff is repeated from there to there. It works. Read the first value. Is the value invalid? Yeah, display an error message, read another value. So counters. A counter is a variable that's incremented or decremented each time a loop repeats. It's also known as the loop control variable if it's used to control the loop. And it has to be initialized before entering the loop. And all those examples I did with x is less than, 5 or whatever, those are all counting loops. Stuff like this. Int x is equal to 1. While x is less than or equal to 10, print happy birthday. And then add 1 to x, so it's not an infinite loop. X is our counter, because it's counting from 1 to 10. It's a loop control variable, because it's being used to control the loop. Now there's another way of writing this. This is what's known as the init phase. We initialize. You always have to initialize your counter before you go in it. This is the comparison, the Boolean expression that has to be true or false, and this is where we update our loop control variable. The for loop lets us do all of that in one fell swoop. And it looks like this. And you just get to tell me which one you like better. For int x is equal to 1, x is less than or equal to 10, x plus plus. See out, happy birthday. I like the second method. I think it looks a lot cleaner. I make fewer mistakes when I do it. So what part is this? This is the initialization step, just like that. What part is this? This is a logical expression, the comparison. And what is this? This is the update that is performed once the body of the loop is performed. So it goes in here, it sets x equal to 1. Is that less than 10? It sure is. So it performs the body of the loop, it prints that out, and then it adds 1 to x. Now it's ready to check it again. X is now equal to 2. Is 2 less than 10? It sure is. Repeat the body of the loop, add 1 to x, so x is equal to 3. Comes back up here. So this is only performed once, right? Maybe it looks like it's going to happen over and over, but it really is only performed once, because this is just a fancy syntax for doing this. And I said a little while ago that there's nothing you can do with a for loop like that that you can't do with a while loop, and vice versa. But this lends itself for counters, doesn't it? because you set a starting position, you set an ending position. So for loops are great for counters. You can leave off any part of it though. If you don't want x to get increased each time, you just delete that. If you don't want to initialize x because something else initialized it up higher, you could delete that. The syntax looks goofy, doesn't it? What's that colon there for? It looks like a little winky smiley face. But all this is saying is that there is no initialization step. If you want, you could delete all three of these things. And that's just an infinite loop right there. No initialization, no comparison. Since there's no comparison, it's never false. So, in the example below, x is our counter, and we're using the counter as our loop control variable. So it's a counting loop. And this is the same. In the for loop, I guess I'll just say the for loop below does exactly the same thing as the while loop above. So your general syntax for loop. For, you have your initialization step, you have your condition, you have your update. And then inside the parentheses, you have your body. Whereas for a while, you have your init, and then you have your while condition, and then you have your body of your code, and then you have your update. The textbook may call these phases something slightly different, but that's the idea. So, this is the same code. Minimum number is 1, the maximum number is 10, and then apparently we're going to print out all of the numbers and their squares. So while the number is less than or equal to the max number, print that number and then print out its square, and then increment the counter. Let's do that in two ways in our code. Let's go back to main, and I know that I added some extra code here. I'm going to delete that. At the bottom of main, before your system pause, we're going to do a little bit. Let's create a counter, which I'm just going to call C. And I'm going to set it equal to 1, and I'm going to keep repeating while C is less than or equal to that x, that number that they typed in up above. We ought to give that a better name than x, right? We ought to call it limit or something like that. Maybe we'll rename all the x's to limit before we're done. And so inside the loop, we're going to print out that number, and then we're going to print out a couple of tabs, and then we're going to print out that number squared. POW x to the power of 2, followed by an ENDL. And we better add one to C. Now I just made a mistake. Does anybody see my mistake here? What am I printing out compared to what is my counter? What is it going to print each time?
1.
Or whatever they typed in. If they typed in 10, it's going to print out 10 every single time. So I need to change that to a C. In both places. Print out C and then print out, C squared. And let's make it go up by 2s because we asked for an even number. So how about C plus equals 2? So enter a positive even int. I'm going to type in 20, and it's, I should not have initialized it to 1 if I wanted even numbers. What would have been a better choice? 2. 2 would have been a better choice. So I'm going to put a comment here. 2 is the first even positive int. It's a little mathematical weirdness that 1 is not a prime number, even though you'd think it would be. And it's because of the ultra strict definition of a prime number, which is it's a number that is evenly divisible by itself and 1, which could be taken as meaning, or that it has 2 divisors, itself and 1. And if it has to have 2 divisors, okay, anyways. So that's how you write that with a while loop. Let's do the same thing with a for loop. For, I'm going to use a different variable other than C, maybe D. Int D is equal to 2, while D is less than or equal to X, D plus equals 2, and I'm going to print out D the same way that I printed out C. C out D, and then arrow arrow slash T, 2 tabs, and then arrow arrow POW D to the power of 2, followed by ENDL. Now those things do the same exact thing. Logically, they are equivalent. Let me make sure it works before I brag too much. Yeah, it worked. I don't know if y'all have an opinion about which one you like better. But the right opinion is that one. No, I'm kidding. I'm kidding.
I don't know, my program's telling me that's false.
Pardon me?
I said my program is telling me that's false.
Alrighty. I'm sorry I was making noise during your joke, so I didn't get to laugh at the right time. Just like Steve Martin says that in comedy, timing is everything. Alright, joke because that was horrible timing. Okay, so that is the difference between the while and the for loop. And we could rewrite this to be a do loop as well. I don't really care about do loops very much because I don't have any circumstances in my mind where you have to do the check after you've already executed the body of the loop. But it does get rid of that priming read business. We could write something that did that data entry that we did up at the top with a do. And so let's go ahead and tack that on here. Let's do, I guess we could just reuse X. But do this stuff. C out, enter an odd positive int, colon space, colon space, semicolon. And then let's let them type it in. CIN into X. And then let's put in our while clause. While X is less than 2 and X mod 2 is not equal to 0.
Is that under the bracket?
Yeah, that's after the bracket, like that. You can put it on the same line if you so choose, just like you could put that there. That's stylistic differences. There we go, like that. Now this one's kind of lousy because it's not going to tell you what you got wrong. But it doesn't have the priming read. So validate, you know, it's kind of good that way. We could put some if statements in here, you know, that said, well, if it is 0, then it's bad, and if, you know, if it's not even, then it's bad. We could do all that. That's an example of a do-while loop for some kind of data validation. It's not my preferred way. The preferred way is the one that I put up in the module.
Wait a minute.
Something behaving weird. Let me come look.
We will X. Can we enter an even complement sure?
Oh, you're right. I wrote this. I told them to make it odd, and then I checked for even. So, to make my code correct, you just made yours correct by changing the prompt, but I'm going to change that right there. like that. That will actually force them to type in an odd int. Very good catch, Daniel. So the do while loop, we've already explained it. Do something while expression. And this is the one time where you put a semicolon after your logical loop structure. You don't do it for, you don't do it for while. And you could, I'm going to show you something dumb. If you really wanted to, you could put a semicolon there. If that made you feel good. You could put that there. But nah, you're not going to do that. But that one is necessary. Otherwise, it just doesn't know where the end of it is. Alrighty, so the logic of a do loop. You do some statements, then you check your expression. And it's post-test, so the check happens after you do your code. The loop always executes at least once, right? Because it does the body of the code before it does the check. And then the for loop. The one loop that binds them all and into darkness. Okay, anyways. So useful for a counter-controlled loop. It's got an initialization, it's got a test, which I was calling it the condition, and then it's got the update. And then you can have, you know, a block of statements or just a single statement. And you don't need a semicolon in it. Well, you have to have one there, and you have to have one there. So it performs the initialization. It does the test. If the test is true, it goes ahead and executes the block of code there that's subordinate to it. If it's false, it terminates the loop, bails out of it, or it didn't get into it. Yeah. So if this condition is false, even though it initialized, like if this said x is equal to 10, and then our test was if x is equal to 0, it wouldn't run the code because it's a pre-test loop, just like the while loop. It would check that and then go, no way, Jose, and so it wouldn't do that. So it executes the body of the code, then it reevaluates, then it performs the update, and then it reevaluates the test. All right, so we need some kind of homework based on loops. And I know I have one from previous semesters, but I'm going to go ahead and make another one. So, write a for loop that counts from 1 to 50, printing the numbers. Write a while loop that counts from 5 to 10, printing the POW of the number to the power of 2, printing the squares. Write a do loop that counts from 20 to 10. So you're going to be using minus minus rather than plus plus or anything like that. And let's write one more that skips, you know, by tens or something. Write a for loop that counts from 0 to 20 by 5s. So that's a real short assignment. If you get stuck on it, go back to our notes, look in the book. Everything except for the for loops is stuff that you've already done in Python. So, excuse me, everything except for the do loop. The for loop we did in Python was a little bit different, right? Because here's what our for loop looked like here. To do that for loop, we would have done for x in range 1 to 11, skipping by ones, right? And we wouldn't necessarily have had to add that, but because that's the default. So that's the same thing in Python. I just put that in there so that you know, do a little bit of comparative anatomy. Print happy birthday. All right. I hope that homework made sense. Let's make a Dropbox so you can upload what we did today. Then I'll prettify the homework and upload it. Yes, sir. Need help? All right. Sorry, I did not do enough walkabout.